All right, everybody, welcome to Math with Grace. All right, everyone, for today's lesson, we're going to be looking at Pre-Algebra book 809, lessons 6 through 9, and those are on pages 22 through 40. All right, so we're going to be starting with permutations. A permutation is the number of different ways that we can order a limited number of options without using them more than once. So if we look at the example that's in the book on page 22, it reads that Mr. Sneller teaches 5 different 8th grade classes. He teaches math, language arts, Bible class, science, and social studies. Okay? He teaches these every day in his classroom. He must decide in which order to schedule each subject in the 5 class periods. How many different ways can he schedule these subjects? Well, when we were talking about permutations, we can't use anything more than once. If he schedules math class first hour, he's not going to schedule it again third hour, right? He only teaches math once a day. So for his first hour class, he has how many options? He has 1, 2, 3, 4, 5 options, right? So for his first hour class, he has 5 options. For his second hour class, he has one less option. It doesn't matter which one at this point is chosen, but he has one less option. So now he only has 4 options. Third hour class, now he only has 3 options. Fourth hour class, now there are only 2 options left. And then his last hour class, there's only 1 option. So no matter which you choose first, these are our number of options each level, okay? When we multiply these all by each other, we end up with 120, which is the different ways that he can arrange these 5 classes. He could have 120 different class schedules if he so chose, organizing these classes each in a different order. Now let's look at problem number 1. It says Gail had a can of baby powder, and I'm just abbreviating these for simplicity, okay? A jar of Vaseline, a container of baby wipes, and a pin cushion on her shelf, okay? After Gail removed all the items to dust, she took down all of her items. How many items? Let's first take a look. How many does she have? She has 1, 2, 3, 4 items. Okay. After Gail removed all of the items to dust, how many different arrangements were possible when she placed these items back on the shelf? Well, she only has 4 items, so she can only put 4 things back, right? So that's the number we're going to go for. In her first option, she's going to have 4 choices. In her next option, she's only going to have 3 choices. Then 2, then finally 1 option. If we multiply these all by each other, we know that Gail has 24 different possible options for her baby products to go back on the shelf after she finishes dusting. Okay, this is a permutation. This is how we work these out. Let's take a look at number 2. Problem number 2 reads, the Weavers often ride their bikes in the park that has 3 entrances, or 3 different rail trails, leading off from the parking lot. Okay, so from the parking lot, there are 3 different trails. All right. If they were to ride all 3 trails in one afternoon, how many different orders could they ride the 3 trails? Okay. Well, let's take a look. We've got a total of 3 trails again. So the first time they can choose 3 options. The next rail choice they take, there's only 2. Then there is only 1 option. Okay. So their number of varieties of different orders in which they could take these trails is 6. Okay, their pure permutation for this is 6. There are 6 different ways that these can be arranged. Now, if you're curious what a rail trail is, there's a little note on the side of the page. It tells us that rail trails are abandoned railroad lines converted to recreational trails by removing the rails and ties, and the rail bed has then been maintained for hiking, biking, and horseback riding. Okay, so that is our lesson number 6 on permutations. Now for lesson 7, It's titled Which is the Better Buy? And they are trying to teach you a different method of distinguishing which item, two items sold at different quantities, right, is a better buy. Now, feel free to read through the lesson. I'm not a big fan of the way this is presented, so I'm going to just work through some of the problems with you now, and we'll see how this goes, all right? So, question number 1 reads, Gail needs more kibble for her dog, right? A 20-pound bag, so we've got 20-pound bag, costs $5.99, all right? And a 50-pound bag costs $14.74. All right, which is the better buy? Now in their lesson, they are talking about how 20 is 2.5 times smaller than 50, so you can multiply it by 2.5, but let's just think of it in a slightly different manner, okay? Yes, 20 is 2.5 times smaller than 50. So if we think of the 20-pound bag as being worth $6, okay? Well, to get up, we want to see how much do we need of these 20-pound bags to get to equal this 50-pound bag, okay? So we need, if we multiply it by 2, that'll give us 40 pounds, right? So we know that 40 pounds, okay? And we're just going to estimate this as $6 just to make it easier. We're just getting a general estimate as to which might be the better price. So a 40-pound bag, if this were just about $6, then we know that's 2 of them, right? So that would be $12, okay? 2 $6 bags is $12. Now we're at 40 pounds. We only need half more to get to 50 pounds, right? So 50 pounds of this type of dog food would mean that we would need 1/2 of a bag, right? Well, if one bag is basically $6, then a half bag would be $3 more. If we add our $3 more to our 12, so now we have $12 for our 40 pounds, plus the $3 for our half bag. Not that you can actually buy a half a bag, but they're just trying to estimate which is the better price, okay? 12 plus 3 gives us a total of $15. So if it was possible to buy 2 1/2 bags of this dog food, it would cost $15. So which is the better price? Well, the better price is the 50-pound bag because it's only $14.74. Now, it's not that much cheaper, but it's still the better price in this scenario. Let's take a look at number 2. Problem number 2 reads that Gail is purchasing bird feed for her birds. A 40-pound bag, okay? 40-pound bag costs $14.98. And a 20-pound bag costs $6.98. $6.98. All right, which is the better price? Again, we're going to estimate here, right? This is basically $7, right? 20 pounds is half of 40. So if we had 2 20-pound bags, okay, so that would be it would be 2 times our $7. If we bought 2 of these bags, it would cost us approximately $14. Okay, that being said, which is the better price? Well, because if we bought 2 pounds and it's only $14, which is less than the 40-pound bag, that tells us that the 20-pound bag is a better price. It's a better price for us to purchase 2 20-pound bags if we want 40 pounds of bird food. But that's a lot of bird food. Goodness gracious. Those are going to be some chubby birds. Okay? 20-pound bag in this scenario is the better price. And as you can see, before we were getting exact numbers, it was exactly this much cheaper or exactly this much more. Here, they just want an estimate. If you were just glancing could you quickly figure out which one would be the better price? And this is what they're looking at. Not exact numbers, but which one would be the better price. So let's take a look at number 3. 3 reads that Gail bought sunflower seeds to mix with her bird food. Okay, a 5-pound bag of sunflower seeds cost $3.10. All right, the 6-pound bag cost $4.09. All right, which is the better price? Now here, because I can't just double the 5-pound bag to make 6 pounds or half the 6-pound bag to make 5, right? They don't work out that way. So honestly, here, the best method, rather than trying to multiply by a fifth or some ridiculously strange fraction, the best method really is the old tried and true method of taking our price and dividing it by our quantity. Okay, so we're going to take our price on each of these and divide it by our unit quantity. All right, so $3.10 divided by 5 gives us a total of 62 cents. Okay, these sunflower seeds here are 62 cents a pound. Now, if we take our other bag and we take $4.09 and divide it by 6, we get 68 cents a pound. Okay, so for here, we're paying 62 cents a pound. Here, we're paying 68 cents a pound. That tells us that our 5-pound bag is the better price for sunflower seeds. Okay, like I said, here we could easily double it. Here we doubled and then took a half a bag. This problem does not work out that way. We just need to do it the regular tried and true method, taking the price divided by the number of units to give us the price per unit. All right, and that's our lesson on the better buy, lesson 7. All right, let's take a look at lesson 8. Lesson 8 is rounding according to significant digits. When we round according to significant digits, we always want to round to the same number of significant digits as the number with the fewest significant digits. So let's take a look at example 1. Okay, example 1 on page 31. It reads, in the last chapter of Job, God tells us that Job had 14,000 sheep. Okay, how many sheep did Job own if his flock increased 24% the following year? Okay, well, he started out with 14,000 sheep, right? And his flock increased 24%. So we're going to multiply that by 124%, because if we remember, when we multiply by 100%, we get our starting number again. Okay, so we want our 14,000 plus the 24%. So we want to multiply by 124% because that will give us our starting number plus the extra 24%. Okay, but can we multiply by this 124% as it sits? No, we cannot. So we want to take 14,000 times 1.24. That is the decimal version of 124%. When we do that, it gives us 17,360. Okay, now here's where our rounding comes in to significant digits. All right, our original number, 14,000, has only 2 significant digits. Okay, so when we're rounding based on significant digits, we want our 17,360 to only have 2 significant digits. Here we have 2 significant digits. Our answer should contain 2 significant digits. So when we round this, we're going to round this 7 based on this 3. Okay, that tells us that Job had approximately 17,000 sheep. Right, and that's how we round according to significant digits. All right, if we look at problem number 1A, it's set up already for you with the answer. Okay, 3,400 minus 348 equals 3,052. Okay, that is math. That's what it is. What they want us to do in these boxes they've provided is supply the number of significant digits. this first number, 3,400, has only 2 significant digits, while this number, 348, has 3 significant digits. So our answer, because we're rounding according to significant digits, should only have 2 significant digits, okay? And these are always going to be the largest of the digits, okay? We're talking about thousands here, so that's what our answer is going to be. So we're going to round our 0 according to our 5. So that's going to make our 0 round up to a 1. So our answer, when rounded according to significant digits, is 3,100. Looking at part B of number 1, we've got 0.407 times 110, giving us an answer of 44.77. Okay, what are our significant digits here? Well, we have a decimal place, and we've got a 407. There are no zeros before the 4. There are no zeros after the 7, so we have a total of 3 significant digits. If we look at our 110, just like over here, we have a 0 on the right, but no decimal. That tells us that we only have 2 significant digits. Therefore, our answer should only have 2 significant digits because it's the smallest number. So here are our 2 significant digits. We're rounding our 4 based on our 7, and that tells us that our approximate answer is 45. Part C of this problem is 820 plus 17 plus 96, which equals 933. Let's take a look at our significant digits. 820 has 2 significant digits, 17 has 2 significant digits, and 96 has 2 significant, 2 significant digits, okay? Altogether, they have each, the lowest, they all have 2 significant digits. So that's the number we want in our answer, okay? So here are our 2 significant digits. We are rounding our 3 based on our 3. So our answer is 930. Not 930. That's the number of significant digits we need for that answer. Looking at number 2A, we've got 0.702 minus 0.072. Okay, and that equals 0.630. Let's take a look at our significant digits. For this number, okay, we have 3 significant digits. And for this number, 0.072, we only have 2 significant digits. So our lowest number is the 2 significant digits. So here are our significant digits. We're rounding our 3 based on our 0. So our answer is approximately 0.63. Number 2, part B, is 8,070 times 160 equals 1,291,200. Okay, let's take a look at our significant digits. Here our 0 is in the middle, so it's considered a significant digit, but here we do not have a decimal, so this 0 at the end is not. So we have 3. Same thing applies to this 160, okay? We have 2 significant digits. Our answer should only have 2 significant digits. Here they are. We're rounding our 2 now based on our 9, and that tells us that our answer is approximately 1,300,000. All right, our last one we're going to look at for today is problem number 3. Now it's a division problem, so it's slightly different, right? We've got 204 divided by 108. We still want to figure out the significant digits for each of these, so let's look at our 108 first. Because our 0 is in the center, it's considered a significant digit, therefore we have 3. Same goes for this 204, right? Our 0's in the center, we have 3 significant digits. Therefore, our answer should contain 3 significant digits, all right? Now we're going to round this 8 based on this 8, so our approximate answer is going to be 1.89. And this is how we round according to significant digits, okay? First step is to figure out how many significant digits we have for each number, figure out which is the lowest amount of significant digits, and then we round our answer based on our lowest amount of significant digits. Our final lesson for this week is rectangle graphs. We are not studying rectangle graphs, okay? So You do not have to do rectangle graphs in the lesson. You are, of course, required to do all the We Remember problems and the mastery drill, and if there were any skill builders, but there aren't. So you're still required to do the homework for that lesson, please. You just do not have to do the rectangle graph number 29 or, what was it, 1 and 2? Oh, sorry, dropped my pen. Problem number 1. So you do not have to do problem number 1 or problem number 29, but you do have to do the rest of the work for this section. Please do not forget to do your quizzes and your tests and return them to me via email, or you can mail them to me if necessary. And if you have any questions, please contact me. Everybody should have a way to contact me. And I'm happy to work you through some problems if you're confused on something. All right, until then, we will see you next week.